From the outset, Ambient System has been striving to introduce innovative technologies to communications market. Our history is one of the continuous development and adaptation to the changing needs of the industry, market requirements, and customer expectations. One of our main goals is to solve common deficiencies and limitations in voice alarm and public address systems. Over the years, we have implemented many solutions responding to market and customer needs. For example, networkability and low latency, lossless audio in the TCP/IP domain, and this ability to adapt is a major advantage of our company. The latest Ambient System project has been created in response to such a need. Current technologies, although advanced, often do not guarantee full intelligibility of messages and therefore do not meet their full potential. smartVES is the answer to those challenges. Our goal is to make voice evacuation systems more intelligent and therefore effective. We want all PAVA messages to be clear and understandable, regardless of the acoustic or technical conditions on site. That is why we have developed new smartVES technology that improves in fully automated way intelligibility, which can be evaluated in objective and subjective tests. Let's focus on the main challenges of voice alarm systems, which are to understand the requirements, ensuring that the voice alarm will meet the needs of the client, occupants, and last but not least, fire regulations of the building. Design the system elements to maximize cost efficiency and convenience during installation. To ensure the equipment meets EN54 standards. To select the appropriate loudspeaker type and layout to achieve desired levels of intelligibility. We have to understand the effectiveness of the PAVA system depends on the intelligibility of the speech it can generate. In a standard PAVA system, to tackle bad acoustic, like long reverberation times, the only answer in the market until now has been acoustic adaptations, introducing acoustic plaster, sound-absorbing panels, buffers, etc. The second response could have been specific loudspeaker design, like for example, using dense ceiling speaker grids, line array speakers, tunnel horn, and so on. Finally, during commissioning stage, engineers could deploy advanced digital signal processing, features of modern PAVA, such as equalization and time alignment, to optimize the system performance. However, none of these measures adapt to the dynamic changes in the building life cycle, such as constantly changing type of noise and its level, occupancy, and modification of the building functions over time. To achieve this, PAVA system requires a dedicated sound engineer working 24/7, constantly tuning the system parameters to optimize its performance in the given conditions. If we had a sound engineer on board ready to make the system adjustment to meet its highest intelligibility, he or she would adjust EQ to maintain signal-to-noise ratio in the key octaves for intelligibility, unmasking vital parts of the speech signal. Adjust the overall level to be at least 6 dB above background noise levels. Educate users to speak more slowly and clearly, improving their speech delivery. And that is exactly what smartVES is doing. The first component of the system is the smart ANSM01 microphone. Each microphone is specifically designed to measure background noise in the range of 50 to 120 dBA. The microphone has a flat frequency response in the range of 20 Hz to 20 kHz with a tolerance of ±2 dB. This microphone is a key component of the system, enabling accurate measurement of the acoustic background at the site. With those measurements, the system is able to monitor acoustic conditions and adjust operation according to the noise level and frequency characteristics. This lays the foundation for smartVES intelligent sound control and improved message understanding in difficult acoustic conditions. The second system component is the smart AMAP6, an aggregation point, which has the task of digitalizing the signals from up to 6 measuring microphones and sending the data to the smart DU1604 processor over TCP/IP network. Finally, the last, most important element is the smart DU1604 processor. It is responsible for implementation of the AF and STTA algorithms. Both algorithms are based on the sensor readings provided to the smart DU1604 audio processor by the smart ANSM01 microphones. In case of the loss of communication with the sensors, the processor returns to the saved default settings known as safe mode. A single smart DU1604 processor can simultaneously process up to 16 audio streams, which can support AF for up to 16 speaker zones. At the same time, the processor has capacity to implement the STTA algorithm for up to 4 microphone stations. Ambient System has worked with scientists from Gdańsk University of Technology to create algorithms and devices which are able to modify spectrum of broadcasted messages in real time. They can also unmask critical frequencies for maximum intelligibility and change the tempo of spoken messages without loss of pitch, dynamically adapting to poor acoustic conditions. Those algorithms are patent protected. The speech temporal transposition algorithm, STTA, naturally and evenly changes the pace and duration of messages spoken in real time through smartVES system microphones. The algorithm can distinguish the type of the voice, male, female, the rate of speech, and based on the value of this STI index measured in auto calibration process, slows down the speech accordingly.
Attention! A fire hazard has been detected. Please immediately leave the building via the nearest emergency exits. Attention! A fire hazard has been detected. Please immediately leave the building via the nearest emergency exits.
STTA works in subjective method domain. To explain this, it means that subjective tests, for example of logatomic expressivity, were performed on a large group of listeners under 4 different acoustic conditions, including operation of STTA algorithms. It has been shown that use of the STTA algorithm, developed by a team of researchers at Gdańsk University of Technology and implemented in the smart DU1604, increase speech intelligibility in reverberant conditions. During the normal system operation, the smart DU1604 has to modify speaker output based on the live data collected by the smart ANSM01 noise sensing mics. This is the adaptive filtration AF algorithm, which works autonomously.
Attention! A fire hazard has been detected. Please immediately leave the building via the nearest emergency exits. Do not use elevators, escalators, or cars. Attention! A fire hazard has been detected. Please immediately leave the building via the nearest emergency exits. Do not use elevators, escalators, or cars. Attention! A fire hazard has been detected. Please immediately leave the building via the nearest emergency exits.
The algorithm changes the frequency response and amplification of the sound reproduced by loudspeakers based on the calibration parameters and the current spectrum and level of the noise. smartVES ensures the highest STI possible to achieve on the given conditions and maintains appropriate headroom 5, 10 or 15 dB between the useful signals, for example spoken messages, and any noise background. While developing the algorithm, we have completed many different tests. For example, we compared STI improvement introduced by the smartVES AF algorithm against typical ANS and passive system for different levels of the noise and different speaker types. Those tests show clear improvement in STI for all speaker types over a wide dynamic range of background noise, compared the result of simple automatic gain control based on noise sensing. Visible differences between loudspeaker types, loudspeakers with higher efficiency or higher maximum SPL perform better on average at higher noise levels than loudspeakers with lower outputs. The typical horn speakers, despite its weaker performance at low background levels, allows a very large improvement at the highest measured noise levels. Other type of test was based on one type of the speaker but different characteristics of the noise. With the same signal-to-noise ratio, adaptive filtering performs better than full band level control INS type. Obtaining a higher improvement in speech intelligibility at higher noise levels is more pronounced in case of narrow band noise, which interferes with the speech band. This indicates the effectiveness of the AF algorithm's intelligent control of the gain in the individual subbands. At the same SPL level and SNR, the energy of the smartVES controlled signal is concentrated in the bands, providing higher improvement efficiency, whereas a signal controlled by ANS encounters the loudspeaker's maximum output performance earlier at the lower noise levels. How does the system work? First, we need to perform the system calibration. The first step is the mic pairing procedure. In short, we recognize where the microphone is connected and which speaker zone it serves. The next step is collecting important system and room data. Calibration takes place in low noise conditions. It means no more than 50 dBA. On the basis of 3 measurement signals played back in sequence, STIPA modulated signal, low-level pink noise and high-level pink noise, we perform the procedures like resolving effective acoustic bandwidth, resolving transition function between the transmit and receive path, calculating STIPA acoustic signal levels. Auto-calibration is essential for obtaining key information about facility and the installed system. From those 3 signals, the system determines important parameters such as the reverberation time of the room, RT60, loudspeaker characteristics, maximum and minimum sound levels, and the acoustic characteristics of the room itself. These parameters form the basis for calculating the coefficients used in adaptive filtering in real-time system operation. In other words, self-calibration provides the system with vital information about the characteristics of both the room and the loudspeakers, allowing the frequency response of the loudspeakers to be adapted to changing noise levels and broadcast messages during system operation. In conclusion, we measure speaker performance characteristics and the acoustic parameters of the venue. Ambient System smartVES is a new chapter in voice alarm systems technology, using advanced algorithms to dynamically enhance speech intelligibility. Components like Smart ANSM01 microphone and Smart DU1604 processor implement adaptive filtration and the speech temporal transpositional algorithms, significantly improving the clarity across diverse acoustic conditions. smartVES marks a transformative leap in the voice alarm and public address systems, offering intelligent features that elevate speech intelligibility in the real time.